Exploring odd integers as sums of three modified primes. Aaron Cattell. June 2, 2025. Abstract. This paper investigates the decomposition of odd integers n greater than or equal to 7 as the sum of three elements from a modified prime set P equals 1 a union set symbol of primes. Specifically, we analyze the function fn, defined as the mode of the largest primes in the last three lexicographically ordered triplets summing to n. By generating data for n up to 1000, we identify intriguing patterns and connections to classical conjectures, offering a heuristic yet systematic approach to additive number theory. Introduction. Goldbach's ternary conjecture, proposed in 1742, asserts that every odd integer greater than 5 can be expressed as the sum of three primes. While this conjecture has been largely confirmed computationally, it remains an area of active research in additive number theory. Interestingly, the historical consideration of 1 as a prime before the 20th century inspires a modified analysis. We consider the set P equals 1 a union set symbol of primes O, and explore representations of odd integers n as sums of three elements from P. Methodology. Given an odd integer n, we define triples n equals P1, P2, P3, set membership symbol P, 3 P1 less than or equal to P2 less than or equal to P3, P1 plus P2 plus P3 equals n. The function fn is then defined as fn equals mode max P1, P2, P3, P1, P2, P3, set membership symbol last three of triples n. We generated data for n from 7 up to 1000, computing fn for each. Results. Figure 1 shows the plot of fn across odd integers up to 1000. We observe that fn closely follows n2, with deviations occurring where n2 is not prime. 1. Figure 1, plot of fn for odd integers 7 less than or equal to n less than or equal to 1000. Discussion. Our analysis demonstrates a consistent pattern. For most odd integers, the largest prime in the final triplets approximates n2, with minor deviations corresponding to the gaps between consecutive primes. This heuristic enumeration highlights both combinatorial richness and structural stability in additive representations of integers. Conclusion. By including 1 in the prime set, we expanded the range of valid decompositions of odd integers into three primes. The behavior of fn across a broad spectrum suggests deep underlying regularities that align with the spirit of Goldbach's conjecture, even in this modified setting. References. 1. Goldbach, c. 1742. Letter to Euler. 2. Hardy, G.H., and Littlewood, J.E., 1923. Some Problems of Partitio Numerorum. 3. Cattell, A. 2025. Heuristic enumeration of odd integers as sums of three primes including 1 as a prime. 2.